Welcome to the lecture 2 of this Python programming course. We'll start our discussion on language fundamentals today. We will discuss the concept of identifier, variables, data types, and we'll have a look at the typecasting topic too. So let's get started. So this is the basic agenda today: variables, data types, typecasting, Python objects, and the memory representation of these variables. So we'll start our discussion with the topic identifier. So whenever I take the word identifier, what comes to our mind? So whenever I say the word identifier, so then we will think about identifying someone. Okay, if I have a group of students in a class, and if I enter the class and if I want to uniquely identify someone, then how would I identify them? Either I would call them by their name, or I can call them by their roll number. I can call by their name or roll number, so that I can identify them, I can call them out. So even even if we want to identify someone in a crowd, then how can we do that? Okay, we will, if you want to call anyone, then we are going to call with the name, because with the name we can identify them. With the with the name we can call them out, we can uniquely call them out. So the purpose of identifier is to uniquely identifying something. The main purpose of identifier is to uniquely identifying something. So in the same manner, in the Python programs, if you want to create a data, for example, if I want to create a group of alphabets, okay, if I created a list, this is how we create a list in Python. The square brackets will be there on the either side, and inside the square brackets we'll have the alphabets or whatever data. We can have numericals. We'll discuss about this in the future lectures. So if I want to create a data where I can store the group of alphabets here. So this is a list. So I created this data today and I just left it out in the memory. Okay. Then I came back after 4 to 5 days. And then what if I want to get this memory? Get this list from the memory. I can't get that, because I don't have any name. I haven't mentioned any name for this list. So how can I even fetch this data from the memory? So to fetch this data from the memory, I need something to you know identify this. I need something to identify it. So what if I can maybe I can name this as an alphabet. So after 5 days, whenever I come back, I can just print this. I can print the alphabet, then the output will be generated on the screen. So to identify someone, to identify a data, we need a name. So that's what the identifier concept means. So a name in a Python program is called an identifier. Okay, it can be a class name, it can be a function name, or it can be a module name. It can be anything. Whatever we declare in the program, we need to give that a name. If you're going to create a function, we need to give the function a name. If you're going to create a class, we need to give the class a name. Without giving the name to a class, without giving a name to the function, we can't even call that function. We can't even print the values inside the function or whatever it is. We can't do any operations. So without an identifier, we can't do any operations. We can't do any operations without a name. We can't do any operations without the name. So identifier is important. Identifier, why is that useful? To identify something. Okay, to identify something uniquely, to uniquely identify something, we need an identifier. And name is nothing but the identifier, giving names to the modules, to the classes. So whatever we create in the Python program, we should give a name. So name is nothing but the identifier. So for example, here I created a class and I gave the name human. So here the human is a name, so human is the identifier. So wherever you find a name to anything, that's called the identifier, because we are uniquely identifying it. Okay. So there are some rules to define the identifiers in Python. For example, I created class human. So this is nothing but the identifier here. Okay, this is identifier. or I can call this as a name. This is a name, this is the class name, this is how we call the class. So to write this, I mean, to give a name, there are some rules in Python. Whenever a child is born in our families, we have some rules about how to give name to that child. Okay, we'll arrange a good function. We'll call all the, you know all the relatives, everyone, and we'll take a book. We will go through all the names in that book, and we will have some of our rules based on the nakshatras or whatever the child was born in. So based on the rules, we will name that. So at the same time, to the class or to the function, to the modules, anything, we have some rules in Python, and we need to follow that rules. If we don't follow that rules, Python is going to give an error whenever we execute the program. So if we don't follow the rules, we have some rules. First of all, we have some rules to name something. So if we don't follow these rules, Python will give an error. So the first rule that is that the only allowed characters in Python are alphabet symbols and digits and the underscore symbol. These are the only available symbols that we can use for the identifier. So what are they? The first one is the alphabet symbols. So A to Z or lowercase a to Z. Then we can put digits, 0 to 9, and we can use underscore symbol. So apart from this, like other than these symbols, we can't use anything else. If we use anything else other than these three, then we'll get an error. If we use a dollar symbol, we'll get an error. That's not right. If you're going to use @ symbol, we'll get an error. We can only use underscore symbol, we can use digits, we can use the alphabets. These are the only symbols that are that can be used to name anything. Okay, for the identifier, these are the only symbols that we can use. So the next rule is that identifier should not start with a digit. So I can name something. This is a class, and I name this class as human. So this human, the first letter is alphabet. The first letter is the alphabet. It's alphabet. But the rule 2 states that I can't start the identifier with a number. So I can't write something like this because the name is starting with a number. So I can't do this. That's we will get an error if you write something like this. The identifier cannot start with a digit. Okay, if we start with a digit, we'll get an error. But we can write like this, human, and we can put the digit here. We can put the digit anywhere in the name, but we cannot put the digit in the front, I mean in the first place. So we can even do something like this, H2UMAN. We can do like this, HU23AN. So we can put any numbers anywhere, any times, but the first letter should not be a digit. That's the second rule. The first rule is that the available digits are alphabet symbols, digits, and underscore. And the second rule states that the identifier should not start with a digit. So the next one, the third rule is that identifiers are case sensitive, and Python language is a case sensitive language. So the meaning of case sensitive is that, so if I have two names, for example, if I have human, and if I have the human with the lowercase letter, here the first letter is the uppercase letter, here the first letter is the lowercase letter. Now these two are different. These two are not the same. These two are different. So these two are different. So that's the meaning of case sensitive. So H is different from small h, capital A is different from A. These two are not same. These two are not same. At the same time, capital S is not the same as small s, lowercase s. If I write samosa, I mean with capital letter, and if I also write with a small letter, then these two are not the same, because identifiers are case sensitive. So there is a difference between the capital letter and the lowercase letter. I mean, there is a difference between the uppercase letter and the lowercase letter. And the fourth rule is that we can't use reserved keywords of Python. Reserved keywords are some keywords in Python which have a special meaning in the language. So these keywords are already designed by the Python programmers. I mean, the one who created the Python, they designed these keywords, so we cannot use these keywords as the identifiers. So for example, if I have if is a keyword in Python, so I can't name a class with this name. I can't name like this, so this is illegal. I mean, we can't do this. We can't use any reserve word to name a class, or to name a module, or to name a variable. We can't use any reserved word. So these are the four rules that we need to keep in our mind whenever we are declaring an identifier or anything. These are the four rules. The first one is the allowed symbols are alphabets, digits, underscore symbol, and identifier should not start with a digit. It's the second rule. And the third rule is that identifiers are case sensitive. And the fourth one is that we can't use any keyword for the identifier. So now we'll start discussing about variables. Now we have already discussed about identifiers. So under the identifiers concept, as I said, identifiers is used to identify something. Variables comes, I mean, variable names. We can also talk about class names. We can talk about function names. I can talk about modules. So identifier is a name, okay? We can give it to a variable, we can give it to a class, we can give it to a function, we can give it to a module, or whatever we create. And there are so many others too, like we can create a list in Python, we can create a set in Python, whatever it is. We can create an object in Python. Whatever we create, if we give a name to that, then it's called an identifier. So variables is a concept which is used to store something, okay? So if I have a variable called a, then I can store something. I can store a value in this variable, so that in the future, to get this value, I can just print this a. So print a, then I'll get the output. I'll get the output 100 here. So to store something, we will use variables. Okay, variables are nothing but the memory locations, or I can say that a placeholder. For example, this could be a box, and inside that I'm going to place this 100. And the name of this box is a. So in the future, if I want to know the value of this box, simply I can print this a, then I'll get the value of this box. So variables is a concept of storing data, storing values. So let me show that by executing in the Jupyter notebook. So let me create a new file here. Yeah. So I'm going to declare a variable here. So I'll just name it a is equal to 100. So now a value, called 100 is stored in the memory, and the name of this value is nothing but a. I'm going to print this value, and I can get the output. So in the a, the value 100 is going to be stored. So whenever I print this value a, then this will get printed. So for example, I can also create something like favorite movie. You can call it anything, maybe House of Dragons, and then I can call this print favorite movie. Yeah, the output got printed. Mm, I can also store favorite anime, maybe One Piece. So I can print this one. I can print the favorite anime again. So I'll get the output here. So to store something, I'll use the concept of variable. The value will be stored in that variable, and whenever we want to get the value of that, we'll just call that, we'll just print the variable, then we will get the value to the output screen. So that's the concept of variable here. So I think we already discussed the rules for the identifier. So here, if you look at here, if you look at here, this a is nothing but the identifier. So we are giving name to this variable. Okay, this is a variable, and a is nothing but the name to this variable. So this is nothing but the identifier because we are naming this variable. So like in the Jupyter notebook, I created something called favorite anime. This is a name. This is nothing but a name. I'm naming the variable. So we need to follow the rules of the identifier while naming the variables too. So here I can, if you can see here, my variable, the first letter is not starting with a digit, so it's obviously it's valid. Underscore symbol is allowed in Python. So my variable is equal to 10. So obviously this is valid. Then we have the underscore, and in our rules we discussed that the name cannot be started with a digit, but the name can start with the underscore. So that's what I did here. I started this one with an underscore. So this is valid, and even here I haven't started this one with a digit, so this is also valid. So these are some of the invalid variable names. So whenever we start a name with a digit, then it's invalid because it starts with a number. This is invalid. Here I'm using a different one. This is not underscore, okay? This is hyphen. So we can't use anything. We can't use any other special symbol other than the underscore. So this is also invalid. And this is a reserved keyword. Okay, for is a reserved keyword, which is already designed by the Python programmers who created Python in the past. So we can't use these keywords for the names. So this is also invalid. So here, if you can notice here, I'm using something, I'm using the hash symbol. This one used to write comments. Okay. Comments are the text which will not get executed. Okay, which will not get executed. So here, if you create a variable or if you create a class, if you want to write something about the class, because whenever after 10 days, if you come back to the program and you just want to read what exactly you wrote in the past, then you want to know something about your variables, you want to know something about your classes, you want to know something about your functions, you want to know about your program, then what you do is that you use this hash symbol to write some comments. Okay, I'll show you in the code. Okay. So here, if I want to write a program to add two numbers, I took a is equal to 10 and I took b is equal to 20, and now I want to add these two numbers. I am storing a is a variable here, b is a variable. I'm storing the value 10 into this variable a. I'm storing the value 20 into this variable b, and I'm going to add these two numbers and store it in the variable c. So a plus b, I'm storing it in the variable c here, and then I'm printing this value, and I'm printing the variable. Okay, I'm printing the variable, then I'll get 30. So for this program, I want to write some comments so that whenever I come back in the future, I'll know what exactly this program is about. So I'll write hash here. I'll include hash, and then I'll write the comment, program to add two numbers. So this is how we use comments. We use comments to write something, and whatever we write with this hash symbol, it will not get executed by the Python interpreter, or it will not even considered by the Python interpreter. Okay. So the main concept of the variables is not exactly storing a value in the in the memory location. Okay, whenever I create a variable with a value, it's not exactly storing this value in this memory location. We are actually binding this variable to a value. Okay, we are actually binding it. Okay, in computer science, the equal sign is nothing but, the equal sign is nothing but an assignment. So this equal sign, what it's doing is that it's assigning this value to this variable. It's 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 like it's binding this value to this the variable a. So there is a variable a stored in the memory, so there is also a value stored in the memory. So it's binding it. Okay, it's combining these two things. Thus the a is actually pointing to the 10. It's not that like, especially in Python, like in C language, in Java, it's a bit different. The memory representation of variables is a bit different, but in Python we use the concept of binding, we use the concept of objects. Everything in Python is an object. We'll discuss that in a bit, but as of now we just need to understand that we're just binding these two things. So whenever I use this assignment, the equal to symbol, what I'm doing is that I'm binding this value to this variable, so that this variable will point to that value. So so then, now we need to discuss how exactly we'll store it in the memory. I just now told you that we are actually binding the value to the, you know to the variable. So we need to understand how exactly these variables are stored in the memory. So actually, there are two types of memories. We have something called stack memory, we have something called heap memory. So we have something called stack here. This is stack, and this is heap. So inside the stack, we'll store the global references. Global references are nothing but variables. Okay. We also have something, there are so many types of variables that we'll discuss in the future lectures, but as of now, just understand that global references are nothing but variables. So the variables will get stored in the stack, a, b, or whatever it is. Okay, I created a variable in the Jupyter notebook called favorite anime. This will also get stored here, and the function calls will get stored. Okay, if I create a function called addition, then this function will get stored here. So this is why, this is how the stack memory is used. It is used to store global references, it is used to store the function names, and all this stuff, all the data related to the functions. And there comes another type of memory, the heap memory. This heap memory is usually used for dynamic memory allocation. The word dynamic means runtime. So whenever the program is getting executed, then the heap memory will get allocated. So for example, if in our phone we have WhatsApp. So whenever I click on WhatsApp, the programs of this WhatsApp will be fetched into RAM, into the memory, and the CPU will, all the instructions will be in the memory, and the CPU will start executing instruction one by one. So while executing the instructions, if the memory gets allocated, then that memory will go into the heap memory while executing. So while the programs are in the RAM and while they're executing, if you want to allocate any memory, then all this memory will go into the heap memory. Okay, so that's the main difference between the stack memory and the heap memory. The stack memory is all about the function names and global references. Heap memory is useful to store the data or to store all the stuff during the runtime, during the execution of the program. Okay. So in our CPU, we'll have an operating system. In every CPU, in every computer, we'll have an operating system here. It could be Windows, it could be Mac OS, it could be anything, it could be Ubuntu, it could be Android, anything. So what this operating system does is that whatever program we have, suppose for example I have a program here, we'll just assume a small program here, print hello. This is a line here, and I am just initializing two variables, and I'm just adding these two variables here. So this is a program here. We have a program. So for this program, operating system will create a memory like this, okay, for each and every program in the computer. For each and every program, we have a memory model like this. The addresses will be there here, 0 to maybe max, it could be any address. So all these are the addresses here, and this program is divided into these three, these parts. The top one, it will be stack. This is the empty space here. This is the empty space. Empty space, because the stack will get increased, okay, the stack will get increased down, the heap will get increased, so it will combine with each other, okay. These two will combine with each other. So this is it is divided into stack. This is the first one, and next it is divided. There is a section called heap here, then there is a section called data section, and there is another section called text. Text is nothing but the program. Data is nothing but these variables here. And stack is used for the global references here, okay, and heap is used to store the values, okay. And actually, here the data is not exactly the 1020, because I think here a is equal to 10, b is equal to 10. These two are nothing but objects here, that we'll discuss that in a bit. So data is about the data which is required by this program, okay. If this program has any predefined, if this program needs any data, so that data will be stored here, okay. But the values will be stored in the heap, that we'll discuss in a bit. But the data is not about storing these values. If the program has any, if you take any big program, then you will understand this concept. But like right now, let's just assume that whatever the data related to this program, it will be stored in this module. Here the program will be stored. This is for the stack. This is used for the variables, the global references, and heap is used to store the objects, okay. Heap is used to, I'll let you know, I'll explain you regarding the objects in a bit. We'll discuss about the objects, but I'm just writing it now. So in the heap, objects will be stored, the text, the programs will be stored. So whatever data related to this program, it will be stored here. In the stack, the global references will be stored. So every program, each and every program will have a separate memory model like this. If I have 3 programs, then each program will have its own stack. Each program will have its own heap. Each program will have its own data section. Each program will have its own text section. So it's independent, okay. If I have a different program here, then this will have a different stack here. So there will be a stack for this program. There will be heap, data, and text. So for each and every program, the operating system will create something like this. So let's let's do this example, and I'll try to explain how exactly everything will get stored in the memory here. So this is stack. We just discussed this one. The stack, heap. So I'm just going to draw this one. So this is stack. I'll write it here. Stack, and this is heap. So this is a program. This is the first line of the program, and in Python, all the lines are evaluated one after the other, okay. If you have 3 lines in a program, if you have 3 lines, print hello. We have another like print 2. like the program will execute line after line. First this line will get executed and this line will get executed, and if we have other lines, so it will executed line after line, okay, sequentially. So first here this one will get executed. So num1 is equal to 100. So inside the stack this is a variable here. So num1 will get so here num1 is created here. So this is nothing but the value, okay, this is nothing but the value, and this is also called as object. That we'll discuss in a bit, okay. I'll explain you this one in a bit, but as of now let's just assume that it's a value. So the value will get stored in the heap. I already told you here in the heap we store objects that will discuss in a bit. So 100 will be stored in the heap memory, and this num1 will be pointed to this value, okay, and then num2 is equal to 200. Num2 will be stored here, and this is pointed to the value in the heap memory. So 200 will be in the heap memory, and this num2 is in the stack, and this will pointed to this value. And next, this is nothing but a function here. We'll discuss about functions in the future lectures. So I'll just give you a glance about how functions work. Def is a keyword to define a function. Okay, this is a keyword to define a function. This is name of the function. These are parameters, okay. Parameters are nothing but inputs, okay. The basic understanding of function, I hope you know this. What is meant by a function, okay? If we give input and if we get output, then that's called a function, okay. So here we are giving two inputs, here we are giving two numbers, and we're getting an output. So that's called a function. So even in real life, everywhere, the real world in the universe is made up of functions. If we push a door, then the door will go forward, okay. We are giving an input, probably there is a function developed in this universe. So whenever we push something, we'll get an output, okay. It's like a reaction, like it's an action and reaction. So function is nothing but whenever we give an input, we'll get an output here. So here I'm giving an input here, we are giving two numbers here, and I'm going to return the sum of these two numbers. So the input is xy and the output is x plus y. The input is xy, the output is x plus y. So the inputs are we call these inputs as parameters. We call these inputs as parameters, okay. So this is the function here. So the function will always be stored in the stack. I think I discussed this one. This in the stack memory, all the function calls will be stored, okay. So here add will be stored. So inside this add, the variables will also get stored here. We have x, we have y. I think these are the only two variables we have. This return statement, it's actually not storing anything in any variable. We don't have any assignment symbol here, so it's not storing. So we don't need to write this one explicitly because we haven't created any variable here. We are just returning this output to this function, okay. So this one is a function. This one is completely separate from these variables, okay. This is a function and this is completely separate from this variable. So after completion of this addition, in this line we are calling the function, okay. This is nothing but the calling of the function. Calling means executing the function, okay. It's like running the function. So like how do we run the function? We write the name of the function here and we give the inputs here. So what inputs I'm giving here? I'll rub everything here so that I can point this one. So what inputs are we giving here? We are giving num1, we are giving num2. So what is num1? Num1 is 100, so we are giving 100 as the input here. What is num2? We are giving 200 as the input here. So this num1 will go to this x, and this num2 will go to this y, because we are calling the function name and we are giving these inputs. Okay, we are giving these inputs to this function. So this 100 will go to this x, and this 200 will go to this y. So 100 here plus 200. What's the value? 300. So the 300 will be returned by this function, and it is we are storing this output in the result. So there will be a result created here. A result variable is created here. Result. So what's the value? What we are returning here? We are returning 300 to this function, and this function value is getting stored in this result. So 300 will be created in the heap memory, and this result variable will point to this 300 variable. So that's the basic idea of how the variables will be stored in this stack and the heap memory. And I also want to tell you something here. I forgot to mention that one. So whenever this whenever these inputs are given, whenever the function is getting executed here, what's happening here is that the num1 is nothing but 100, num2 is nothing but 100. So this 100 is given to this x, and this 200 is given to this y. So here what happens is that this x will be pointed to this 100, and this y will be pointed to this 200. I hope you're understanding this. Okay, so we are not actually creating a separate value. We have only one value, but we are pointing the references to the same value, so that we are saving the memory here. Okay, instead of creating another 100, 200 and pointing these two things here, I'm just pointing, I'm not creating any new objects here. I'm just pointing this x to this one and y to this 200. I'm saving the memory here. Okay, so that's how everything works. The variables are stored in the stack and the heap memory. So in Python, the values will be created in the heap memory. These values are nothing but the objects. These are nothing but objects or values. Okay, objects or values. In Python, everything is an object. Each and everything is an object. Even this one is an object. Here I created something called result. Even this one is an object. The value 300 is an object, 200 is an object, 100 is an object. Everything is an object in Python. So that's what we are going to discuss now. Everything in Python is an object. Okay, this is very important thing in Python. So whatever we create, it's an object. So like we need to understand, okay, if I say this, I just now gave a statement that everything in Python is an object. So first we need to understand the meaning of an object. Okay, so before getting into the meaning of an object, we'll understand something called data. Okay, so what is in this world, we have different types of data in this world. So we have integer data, we have characters, we have strings. So these are different types of data. Even in our real world, if you look at this world, if you look at different living beings, so if I can say that in the real world, we have humans, we have animals, we have birds. So these are different types of living beings. Okay, these are living beings, but these are different types of living beings. So at the same time, even when it comes to data, we have different types. We have integer type, we have characters. Integers are nothing but 1, 2, 3, 4. These are the integers. Characters are alphabets, A, B, C. Strings are nothing but sequence of alphabets, A, B, C, D, F, something like that. So, Python also supports different kinds of data. Python supports integers. Python supports this float value. This is float because we have a point here. So that's the reason this is float. Python supports string. Python also supports group of values. Okay, Python supports each and every type of data here. So all these things is an object. Okay, each and everything. This one is an object. This one is an object. This one is also an object. This one is also an object. Everything is an object. Okay, and every object has a type. The word type is very important here, okay? The word type is very important to understand the concept of an object, okay? I'll give you a small example here, okay? And we say that object is an instance of a type. We will come to this we'll come to this statement in a bit, but I just want to, you know, explain you something here. So let's take an example here. So in this real world, let's talk about humans, okay? Humans are nothing but, we can call ourselves as a race, or maybe we can call ourselves as living beings, or we can call ourselves as humans, whatever it is. But I mean, we are human beings, okay? So what does humans have two hands, two legs, two eyes, and we have a nose. So these are the attributes of our humans, okay? Every human, 99% of the humans has these attributes. Each and every human have two hands, humans will have two legs, humans will have two eyes. Each and every human, I mean 99% of the humans or 95% of the humans will have all these attributes. And like, what does a human do? Human can eat, human can drink, human can walk. These are nothing but the actions, okay? These are nothing but the actions performed by a human. These are the attributes of a human. These are nothing but the actions done by the humans, okay? So for every type, okay, there will be an attributes and there will be some actions, okay? In this world, this, like, humans are one of the type. Then if I talk about animals here, for example, I can talk about, okay, let's talk about animals first. We'll talk about animals and we'll also talk about birds. So if I talk about animals, then animals will have some different attributes. They'll have they will also have two hands and two legs, but they'll walk on four, so we'll consider they'll have four legs. Their attributes are different. Maybe their color is different. Maybe if you talk about animals, they're shorter than humans. They are, they are less intelligent than I mean, they're not as intelligent as humans. So that's one of the attributes, no intelligence. And there could be so many attributes for the animals too. And there are some actions for the animals too. Animals will also eat, animals will also drink, animals will also walk. These are the actions. So if I talk about birds, then I can list out various attributes here. So for birds, I can say that birds will have wings, they will have two eyes, they'll have wings, they have two legs. So these are the attributes, and the actions are they can fly, they can eat, they can, they can build nests. So these are the actions done by the birds. So in this world, if you observe this world, we have different types of living beings. So one of the living being is humans. So humans have common attributes. All the humans can eat, drink, walk. And if we talk about animals, animals also have the same attributes, but the attributes of animals are not similar to the attributes of humans. And the attributes of birds are not similar to the attributes of humans. Attributes of birds are not similar to the attributes of animals. And the actions that we humans do are not similar to the actions the animals do. And the actions the humans do are also not similar to the actions the birds will do. So it's completely different. So I can say that we have so many types in this world. We have humans, we have birds, we have animals, and I can list out a lot of types. So the type is something, whenever I talk about the concept of type, so here I wrote the type. So a type is nothing but similar, I can call similar objects or similar items, okay? Let's call it as similar items. So if we group some similar items, we'll call this as a type. Okay, this type of attributes, this type of action, these type of people, these type of animals. Type is nothing but a group of similar items. So if I talk about humans, all the humans have similar attributes. We have two hands, we have two legs. So that's the reason I call human as the same type. All the humans could be same type. So that's the main concept of type, or we can, this is also called as class, but we will talk about this class and object in the object oriented programming. This is not the right time to talk about classes. Let's just call this as a type. Type is nothing but a similar, a group of similar items. So now what is meant by an object then? Okay, if I explained you about the type, but then what is meant by object here? We'll discuss that. Okay, like we'll talk about it in a bit. I'm just erasing all these things. Yup. Yup. Humans have birds, animals. So I created, I mean, I can find, I found three types of living beings on the earth. We have so many times, but for example, purpose, I took three living beings from the earth. So these humans is nothing but a type. Type 1, this is type 2, this is type 3. Okay. So now what is meant by an object here? Object is an real life entity. Okay. This is very important. Okay, this word is very important. We'll also talk, we'll come to the same concepts in object oriented programming. So when we reach object oriented programming, we are going to talk a lot about objects and classes. Please try to understand whatever I'm trying to explain here. Object is nothing but the real life entity. So here I created a type called humans, and I told you that humans have similar attributes, like all the humans have similar attributes. So like I am a human, you are a human. So my name is Vikas. So this Vikas is nothing but an object, because I am the real life entity. Human is, it's like a blueprint, or it's like a virtual imagination, or I can, it's like a type, but I am real. Okay, like we are real, you are real, the one who is watching. Like if you're watching this one and if you have a name, then you are the real life entity. And even if I talk about birds, then like parrot, and maybe we can give some name. We can, let's name this as a, this one is the real life entity. Birds is type, but the real life objects, okay, the real life entities, the real beings are nothing but the objects. Even if I talk about animals, tiger is an object, is one object. Lion is an object, because tiger also have two four legs, lion also have four legs, and these two comes under the type animals. So the animals are nothing but the types, and the real life entities, okay, the real life objects are nothing but the real life beings that we can see. So if I talk about humans as the top level entity, then I am real life entity. Okay, my name is Vikas, then I am real life entities. Then the real life entities are nothing but the objects, and the type is nothing but the virtual, the virtual concept. Okay, it's like a blueprint, or we can call it as the virtual concept. And the real concepts are you know the one that we see in a real life. Okay, so that's the basic difference between an object and data, sorry, the object and type. So now let's come to our statement. Let's come back to our statement here, that everything in Python is an object. So I told you that Python supports different kinds of data. So here we are trying, we can see different types of data here. So this is integer, this is float. Please listen to this concept carefully, you will understand everything now. This is string, these are list. Okay, let me create different another slide here. um, So what I created in a previous slide, integer, float, string, list. Integer, this is a type, string, and we have list. What's the other one that we discussed? Float. Okay, no need to draw this line. Okay. Yeah. So this integer is a type of data. This is one type. This is type one. This is type one of data. All these, everything is data. Okay. Don't forget that we are talking about data. These are types of data. This is type one. This is type two. This is type three. This is type four. Okay. So these are nothing but the types. Then what do we call the objects? I just now said that objects are nothing but the real life entities. This they are the real values. Okay. So for the integer 0, 1, 2, 3, 4, so on until infinity. Each and every value is nothing but an object here. This is an object. This is an object. This is an object. Even -1 is an object. 66, 666, that's an object. 999999, that is an object. So integer is a type because we are combining all this similar type of data into a type. So type is nothing but group of similar items. So all these integers are similar items. That's why we grouped it. What is when object? Object is nothing but the real life entity. So that's what I'm trying to explain here. Even if we talk about string, let's talk about string. My name is Vikas. Vikas is a string. Then let's write Mahabharat. Mahabharat is also a string. ABC is also a string. These are nothing but the objects here. Okay, these are nothing but the objects. String is a type. These are objects. The same goes with list. If I take 1, 2, 3, this is an object. 2, 3, this is one object. You know, so on. Okay, I can make any types of list, and the same goes with float. 2.3 is an object. 3.4 is an object. 4.3 is an object. I can keep on going like this. Okay, this is an object. So I hope you understood the concept. You understood the basic difference between the type and an object. So now I can say that everything in Python is an object because whatever we write, whatever data we declare in an object, it comes under a type. If I declare a list, it comes under the list type. If I create an integer, it comes under the integer type. If I create a floating point, it comes under the floating point. If I create a string, it comes under the string type. So whatever I create, it comes under a type. So that's the reason I'm saying that everything is an object. And in Python, especially in Python, even for the primitive types, we define that with an object. Okay, okay. Oh, I think okay. So if we talk about Java, we have two types of concepts. Okay, we have primitive types in Java, and we also have reference type. Okay, primitive type is nothing but int, float. We can have boolean. All this stuff are primitive types, and the reference types are classes, objects. All this stuff is the reference types. But in Python, both primitive types, both reference type, everything is an object. Everything is an object. Okay, so that's the main idea of this one. We'll also, this one is just the basic introduction to the concept of objects and classes. In object oriented programming, we are going to discuss a lot. Okay, I'm going to take a lot of classes for this one because to if you're going to develop projects in the future, if you're going to understand the software development process, we need to understand the difference between classes and objects. We need to understand how how exactly the objects are stored in the memory. Right now, I'm just giving you a basic introduction to this one because this is not the right time to discuss, each and everything. I mean, but still, I think I have explained you almost everything related to these concepts. But still, in the object-oriented programming, we'll discuss a lot regarding this. So, if you have any doubts, you can comment it. You can comment to this video. You can, or you can wait until we reach the object-oriented programming. Okay. So just like I said you, everything is an object. So everything is an object in Python. So I'll write it again. Everything, everything in Python is an object. And each Python object is PyObject. Okay. Inside the memory, each and every object, okay, each object, okay, everything is Python is an object, and every object in the memory, it's represented in this form. Okay. This PyObject is it's like the base object to all the objects. I mean, look here, we look here, I wrote so many objects, right? 0, 1, 2, 3, all these objects, right? But this one is the base object. So for example, if I want to let's take anything, okay, let's take a simple one, okay, a is equal to 20. So what is the type of this one? Okay, this is an integer. This is an integer. The type is nothing but the integer. So what I'll write here, integer. Inside the memory, each and every object is represented in this format so that the Python interpreter will understand what exactly is going on with this object. Okay. And we have like for every object is defined with these three attributes. The first one is type. So this is an object here, 10 is an object. So the type is stored here. And the reference count. What is meant by reference count? I just explained you here regarding the reference count. Let me show you here. Yeah, here. This is nothing but the reference. Okay. For this 200, this num2 is pointing to this 200. So this num2 is nothing but the reference. And for this 200, y is also pointing. So these two are the references for this 200. How many references we have? 2. So that we are going to store in this Python object for every object. So here, let's assume this is the memory 10. A is pointed to this one. How many references we have for this object? 10. We have only one. So I'm storing it here. What is the value? 10. So that's the basic representation of an object. Take whatever you want. Take whatever you want here. Let's take a different one. Num1 is equal to 2.43. Let's take a different one here. So what is this? What is the type? The type is float. Inside the memory, every object is stored like this so that the Python interpreter will understand about the object. What's the reference count? Num1, only one. We have only one here. 2.43. We have only one pointing to this one. So the reference count is 1. What is the value? The value is 2.43. So that's the basic representation of every object. Okay, you can take any example and try it. Okay, so I'll also show you the representation about how the programmers of the Python who created Python language in the past created this one. So in background, the Py object is defined in the following manner. As I already told you in the lecture 1 that the standard version of Python is CPython, which means this Python is created with C language. So, whenever the programmers of Python created in the 1990s, they use C language to create Python. So this is how they created this Py object. Okay, I just showed you right. I just showed you right here how we are going to represent the object in the memory. So this is how the programmers of who created Python created. You won't understand anything, but I'll try to explain it here. This is the reference count variable. that we saw here, the reference count. This is the reference count variable, and this is the object type. The type, they created a variable here, and they haven't defined the value because the value is you know the value is actually stored in the child objects of this, or the child classes of this struct. But the we don't need to discuss deep regarding the C language, because that's the part of the C language. Like for basic understanding, for pi object is the base address, but it has so many child classes too. So in these child classes the value will be stored. So you need to understand the concept of inheritance if you want to understand this one, but we don't need to talk much about this right now. But just for understanding, I gave this one. Okay, you don't need to worry much about this one. This is how the pi object is stored. Like the Python programmers created when they worked on Python in the past. Okay. So I just want to show you this one, how we are going to so this is x will point. Okay, I'll write here 543. X is pointed to this one and y is pointed to 654. So what I'm going to do, there will be two objects created inside the memory. This is pi object. What's the type? This is integer. What's the reference count? Only one. We have only one pointing to this 543 object. So 1. What's the value? This one. 543. At the same time, in the same manner, another object will be created inside the memory. Pi object. For this one, this is for this one, this is for this one. Type, what's the type of this value? What's the type of this object? The type of this object is integer. I hope you're understanding the object concept. Okay, let me show you here. What's the type? The type is integer. What's the object? The number is the object. So that's what I'm trying to tell you here. So this is the object. What's the type? Integer. What's the value or the object? 654. And the reference count is 1. So let me write something, a code here. Z is equal to y. What will happen now? What I'm doing here is that in this y, I have the address of this this object. So I'm giving the address to the z. Now the z will start pointing to this object. Now what will happen? The reference count will be increased. So 2, because two references are pointing to this object. At the same time, if I write a different, like w is equal to x, then I'm giving the address of x to w, then w will start pointing to this and the reference will be 2. So that's how the objects are stored inside the memory. Like this is the memory representation that we need to understand before going into object oriented programming in the future. But it will take a lot of time to get into object oriented programming, because we need to discuss a lot of stuff. We need to discuss a lot of topics before going there. Right. So I think that's the end of this topic. Objects and variables. I just want to revise it. Variables is nothing but it's like a placeholder. It's like a box where we are going to store a value here. So how we'll store a value? We'll use the concept of binding. Okay, we'll bind the variable. Okay, we'll bind the variable with the value. So what is meant by value? Value is nothing but an object. Okay, as I said, everything is an object. everything is an object. So how we store these variables in the memory? We have two types of memory: stack memory, heap memory. The stack memory, this is how every program has a different stack, has its own stack. Every program has its own heap. So here, the stack will store the global references, the variables, and the heap will store the objects. So everything in Python is an object. We discussed the difference between the type and the object. Okay, we can say that object is an instance of a type. Instance is nothing but it's like like how can we say the instance? Okay, instance is like a part of type. Like Vikas is an instance of humans, parrot is an instance of birds, tiger is an instance of animals. Okay, it's like a part. Okay, that's what instance means. So object is an instance of type. So we discussed how we actually represent these objects inside the memory. We use the py object. This is how the programmers declare the py object using C. So I explained you how references will be incremented. I hope you understood the concept till here. Now we'll start